I am Dr. Ashish Vikhar, and in this video lecture we will see how to determine velocity ratio of compound belt drive. How to determine velocity ratio of compound belt drive. This we want to learn here, how to determine velocity ratio of compound belt drive. For that purpose, we must understand what is the meaning of compound belt drive. In front of you there is one sketch indicating compound belt drive. Compound belt drive, the sketch is shown below is for compound belt drive. In this picture or in this sketch you will see that there are 4 pulleys. This is the pulley number 1, this is the pulley number 2, this is the pulley number 3, and this is the pulley number 4. 4 pulleys are used, and out of that pulley number 2, this, and pulley number 3 are mounted on the same shaft, and all these 4 pulleys, pulley number 1, 2, 3, 4, they are mounted on the shafts which are parallel to each other. So here we want to understand, or we are going to learn how to determine velocity ratio of a compound belt drive. In last lecture we have seen how to determine velocity ratio of a simple belt drive. So in this picture also you will see, if you take this belt drive, simple belt drive, connection between pulley number 1 and pulley number 2, this is a simple belt drive, and another simple belt drive you will see here in this picture as this is another belt drive, simple belt drive. There are 2 belt drives. First belt drive is between pulley number 1 and pulley number 2, and second belt drive is there between pulley number 3 and pulley number 4. So according to the definition of velocity ratio for pulley number 1, for pulley 1 and 2, connection of the open belt is there between pulley 1 and 2. If D1 is the diameter of the pulley 1 and N1 is the speed of the pulley 1, and then we can say that in the same fashion D2 is the diameter of pulley 2 and D1 is the diameter of pulley 2. So according to the definition of velocity ratio for these 2 pulleys 1 and 2, we can write N2 upon N1 is equal to D1 upon D2. So this is a formula of speed ratio or velocity ratio between a pulley number 1 and pulley number 2, and between this pulley number 3 and pulley number 4 we can evaluate the velocity ratio as N4 upon N3 is equal to D3 upon D4. So N4 is the number of revolutions of pulley number 4 and N3 is the number of revolutions RPM of the pulley number 3. D3 is the diameter of pulley number 3 and D4 is the diameter of pulley number 4. So 2 formulas are there for a velocity ratio. First formula, N2 upon N1 is the velocity ratio, N2 upon N1 is equal to D1 upon D2 is the velocity ratio between pulley 1 and 2, while N4 upon N3 is equal to D3 upon D4 is the velocity ratio between pulley 3 and 4. After that we can calculate here how to calculate velocity ratio of this compound belt drive. So 2 relations that we have seen, one is N2 upon N1 is equal to D2 upon D2, D1 upon D2, D1 upon D2, N2 upon N1 is equal to D1 upon D2, and second relation is N4 upon N3 is equal to D3 upon D4. So multiplying these equations 1 and 2, we can write here N2 upon N1 multiplied by N4 upon N3 is equal to D1 upon D2 multiplied by D3 upon D4. So, here finally, if we see that number of revolutions of pulley number 2 in the last pulley number 2, this pulley number 2 and pulley number 3, pulley number 2, this pulley number 2 and pulley number 3 are mounted on the same shaft, and therefore, they will revolve with the speed, with the same speed. So, for pulley number 2 and pulley number 3, we can write here N2 is equal to N3 because they are mounted on the same shaft. So, RPM of the pulley number 2 is equal to the RPM of pulley number 3. So, the finally we can write here, because of this N2 is equal to N3, these two value will get cut down, and we can write here N4 upon N1 is equal to we can write here D1 into D3 upon D2 into D4. This is the formula to calculate the velocity ratio of a compound belt drive when there are 4 pulleys. Okay. So, when there are 4 pulleys, this is the formula to calculate the velocity ratio. If there are 6 pulleys, suppose instead of 4 pulleys, then if there are 6 pulleys, then the formula will become N6 upon N1 is equal to D1 into D3 into D5 divided by D2 into D4 into D6. In this way, we can calculate the velocity ratio of compound belt drive. From this, we can say that the in general velocity ratio for a compound belt drive having number of pulleys, velocity ratio VR for a compound belt drive having number of pulleys is given by speed of last driven pulley divided by speed of first driver pulley. As you can see, this first is a driver pulley and last one is a driven pulley. So, speed of the last driven pulley divided by speed of the first driver pulley is equal to product of diameters of drivers, product of diameters of drivers divided by driver pulley divided by product of diameters of driven pulleys. As you can see in the last formula, D1 and D3 divided by D2 multiplied by D4, D1 and D3, D1 and D3, D1, this is D1 is the diameter of driver pulley and D3 is the diameter of another driver pulley, pulley number 3, and they are here D1, D3 at the upper side and D2 and D4, these are D2 is nothing but driven pulley, pulley number 2, D2 is diameter of driven pulley, and D4, you can see here D4 is there, and this D4 is the diameter of driven pulley number 4. So, here in this way we can say that product of diameters of driver pulley divided by product of diameter of driven pulley, and this way we can calculate speed ratio or velocity ratio for a compound belt drive having number of pulleys. Thank you very much.